What makes specific heat capacity vary between substances? Imagine you have a pot of water and a metal spoon. When you heat them, the water heats up slowly, but the spoon gets hot quickly. Why is that? It all comes down to how different substances store and transfer heat. Specific heat capacity is the amount of heat needed to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. It might seem simple, but many factors influence this property. First, think about the molecules inside each material. The type of atoms and how they are bonded matter a lot. Stronger bonds or more complex molecules need more energy to vibrate or move, which means higher heat capacity. Next, consider how molecules can store energy. Molecules can move in 3 main ways. They can slide past each other, spin around, or vibrate. Substances with more ways to store energy, called degrees of freedom, can absorb more heat without changing temperature much. For example, gases have more degrees of freedom than solids, so they often have higher specific heat capacities. The phase of the material also plays a role. Solids, liquids, and gases all behave differently. Water, which is a liquid, has a high specific heat capacity because of the hydrogen bonds between its molecules. These bonds requiring extra energy to break or change when heated. Metals, on the other hand, usually have lower specific heat capacities because their atoms are tightly packed and bonded in a way that needs less energy to increase temperature. Atomic mass and composition are important too. Heavier atoms tend to have lower specific heat capacities because fewer atoms are present per unit of mass to absorb heat. Conversely, lighter atoms can store more heat energy per unit mass. Environmental conditions like temperature and pressure can slightly change a substance's specific heat capacity. For example, water's heat capacity varies a little as the temperature changes, but these effects are usually small within normal ranges. From a thermodynamics point of view, specific heat capacity is an intensive property. This means it depends on what the material is, not how much of it you have. It tells us how a substance responds to heat energy and how its internal energy changes with temperature. Understanding why different substances have different specific heat capacities helps us in many ways. Engineers use this knowledge to design heating systems, choose materials for insulation, and predict how substances will react to heat in chemical processes or in nature. So, the reason why specific heat capacity varies from one material to another is because of their molecular structure, bonding, phase, atomic makeup, and environmental conditions. Water can soak up a lot of heat without changing temperature much, while metals heat up quickly because they need less energy to raise their temperature. All these factors work together to give each substance its unique heat storage ability.